Hi, I'm Mike Ross, CEO at Indicium Dynamics, and I'm here today to record a video on setting up a flash flood alert system. We're here in Cambridge at the new Richmond Road bypass, and it's an area that's already been subject to a minor flood through this area we're now standing on. And I thought we'd use this as an example of how quick and easy we can set up a flood alert system in the Indicium databus. Let's get back to the office. A fresh deployment of the Indicium databus. It's hosted in Azure with an Azure SQL database for configuration. So there are no connectors deployed so far. Let's start by choosing a data source for the data we're going to base our flood alert system on. Ideally, we deploy some new rain gauges in the actual catchment, but for today's demonstration, we're just going to use a nearby rain gauge, and we're going to use the Bureau of Meteorology's rain gauge at the Hobart Airport. So we're going to start by creating a new connector and actually connecting into BOM AWS, and find in here BOM AWS feed. So we'll save that connector. Now, there was a disclaimer there on the screen briefly. This is accessing Bureau of Meteorology data, so obviously make sure you're using it within their guidelines and their rules. So we've created our new connector. We can see that up the top left, BOM AWS. Let's create a new input, and we'll call that Hobart Airport. And input. We're now into the Hobart Airport here. We'll just set the identifier for the station. We're going to just do a quick search here and see what we can find. So we've done a search for Hobart, and we can find Hobart itself and Hobart Airport. So we'll choose Hobart Airport. And we'll click save, and we're just going to test that. Okay, so in testing that, we can see that it's connected and it's returning a lot of JSON data for each time step. We can see in that JSON data, there's things like Hobart Airport, the name, the timestamp, and if we look closely, we should be able to see the rainfall data. Rain trace, there we are. So we want to extract that rain trace data and do something with it. So let's create a new processing pipeline called extract rain and archive. You can call that whatever you want, but I've chosen that today. We want to extract the rain data specifically out of that, so we're going to use a JSON extract plugin. We're going to come in here, we're going to put in $.rain trace. We'll just fill in these details here. So cool, so all configured. Just going to pop back a level and enable our processing pipeline. And let's just give the whole thing a test. And so far still working, no alarms. The rain data that actually comes out of the Bureau of Meteorology is cumulative data, but it resets at 9 AM. So we need to pre-process this data to save it as rainfall event data, just to make it a bit easier to handle later on. So we're going to add another new plugin, which will be the Decumulate plugin. Because it resets at 9 AM, we want to make sure that when we decumulate that we respect the value it resets to. So we want to make sure that when it resets, if it resets to 0, that point becomes 0, but if there's rainfall at 9 AM, we want to make sure that it resets to 2 or 3 or whatever the rainfall is at that particular time. So we'll use that option. So let's just run a test again so that we run it through the databus. And one of the new features of Databus 3 is that we can actually come in here and see the latest event. So we can come in here and see the rainfall values that were recorded. So that's coming into the decumulate function. We can see here number 5, and it's resetting to 0. We want to store that data, so we're going to store that in a database of sorts. So today I'm going to use Azure storage tables as the location to store that. So I'm just going to find in the list here Azure storage, table storage, and save that connector. Our storage tables connector. The thing we need now is the actual connection string. So I've put that in there. We'll hit save, and we've now got a connection through the Azure storage table set up. If we jump back into our BOM AWS feed, go back through to the processing pipeline, we should now see storage tables in our endpoint list. So we'll select that. We can see here a few little parameters. We're going to change the identifier so that it uses the identifier of the deepest most point of this processing pipeline. That gives us the ability to split the data into things like rainfall, temperature, and so on, and make the IDs unique. And we can choose the table name. So today we're going to call it rain, just to split it up. So let's hit save. And we're going to test it again. We're going to go run pipeline. And we'll select table storage, show last event, and we can see all that rain data there. Now we can see a little rainfall event here at 12 o'clock UTC. So that's got the rain data being extracted from Hobart Airport and archived. If I click this little button here, that'll actually jump us to the storage table entry for that rain data. And we should be able to test that we can see that data coming out of storage tables. So this is actually extracting it straight out of the Azure storage tables. I'm going to click this button here, which is now selected, which is basically saying that once we write data to this storage table record, we want to trigger the subscription pipelines hanging off the storage record itself. We're going to save that. And so what this means is when we execute the BOM AWS download and it writes the storage tables, we can then trigger an event off the raw data. The reason we want to do that is the flood alert system itself will need up to 7 days of rainfall record, and the data we're getting off the BOM's website is only a couple of days. If you're using something like a LoRa sensor, you want to make sure that you can capture that record. LoRa is only going to return the latest rainfall value, so we want to be able to trigger this flood alert system off a historical record. So now we're going to build a processing pipeline off the stored Hobart Airport data, and so let's get started there. So we'll create a new subscription pipeline called Flood Alert. And we'll just pop back and enable that. And in here, we're going to add a BOM rainfall exceedance probability plugin. So we have a few options here already. Do we need to accumulate the data? So if you hit the help here, if you have event-based rainfall, you need to accumulate the data if used by this algorithm. Yes, we did decumulate it, so we need to re-accumulate it. We have a selection mode of custom or preset, so we do have a few preset flood alert curves in the system, but today we're going to use a custom one. And so the next step is we need to actually download a flood alert curve from the Bureau of Meteorology's website. So let's jump in and do just that. So here we are, Bureau of Meteorology's design rainfall data system. Here we can generate an AR&R intensity, frequency, duration curve for the area that we want. So just going to jump in here and select single point. I was hoping I could just jump straight to the map, but that doesn't want to work today. Oh no, we go to this option here. So we'll select from the map. So we're going to zoom in on the area where we know the catchment is. Oops, zoom too far. So we were standing around about here. So let's pretend our weather station is actually up there in the catchment. And let's generate the curves for that. So here we are. It's generated the annual exceedance probability. And we're going to download that as a zip file. Actually, we'll download it as a CSV file. That gets it in the correct format. So I've gone in, I've copied the CSV file, and we're going to paste that into the settings here. And we're going to hit save. And as we usually do, we're just going to run a test to make sure things are working as expected. So we can see no errors have been reported. Let's take this a step further. Let's just quickly add a console step, just a logging step, just so that we can run our tests again. And we'll pop in here and show latest events. So the latest bit of data going into the console. And we can see that it's actually outputted a value. And it basically steps back through time. We have all the calculations that it figures out using those curves to figure out the various rainfall levels, alert levels. And we can see that the max alert level detected was level 2 with a rainfall amount of 0. So basically nothing. But below min, so no alerts to be worried about at this time at all. Analysis on that data. So let's select the IronPython plugin from the list and add it into our pipeline. Just select that there. We'll edit the script and paste in a script I prepared earlier. So this is a very simple script. This is the method that executes when we receive new data. We just log a message up front to say we're about to do something. Here we're turning the data from a string into a JSON object so that we can extract the max alert level and the max message out. And we do a simple check of if the alert level exceeds our threshold. If it does, we log another message and then we return a value containing a formatted message to be sent as an email later on. If we don't exceed our alert level, we just log no alarm and we return nothing, a none object, so that the pipeline knows to stop. So let's save that. And because we want to send an email, we want to send it in HTML format so it's easy to read. So we'll just create a very simple format over here, heading saying flood alert, and we'll inject the value into the email. Okay, we'll just save that all up and we'll run that. Now the rainfall data we've got currently is not enough rain to exceed a level 4 flood level. So if we look here, we can see that the logs run and that it's not an alarm situation. So I'm not expecting to see anything landing in this HTML format. And we can see up here we had last event, no last event found, warning message. Let's pop back in here and change that alert level down to 1, just so that we can say, yes, there is a flood. Run that now. And if we click on HTML format now, we should see that the IronPython has spat out a data message saying, watch and act. Flood hazard level alert 2 out of 18. There has been 0 millimeters of rain in 23 hours and 30 minutes. So it's not really a flash flood, but for demonstration purposes, let's pretend there is. Okay, so if we now click on the next level console, we can see that it has generated HTML email format for us, and we should be able to send that on as an email. Set up a Mailgun email plugin. So I'm just going to push that into a pipeline there. We're going to configure it up with our appropriate settings here. So you need to register for an account with Mailgun, get an API key. You'll then be able to configure the subject and so forth that you want to send. And the list of people you want to send that to. Click Save. Now, once you've entered those few details, you're done. Your alert system has been set up and is ready to go.